Hey guys, welcome. Yeah, so in this video series, I'm going to teach you how to calculate the probability of all 10 poker hands. So there will be 10 videos. I'm going to start with a pair because from a teaching perspective, it's a good place to start. But a pair is the second lowest ranked hand. It's not the lowest ranked hand. The lowest ranked hand is a high card. But a high card is a bit complicated to calculate its probability. So I'm going to save a high card for the last video. So we're going to work on a pair all the way through a royal flush. That will be 9 videos. And then I'll make a video on a high card. Otherwise, it'd be nice if you know a little bit about poker, but that's not mandatory. It'd also be nice if you know a little bit about probability, and all you really need to know is the multiplication rule for probability, and that the probability of an outcome you want is like the desired outcome divided by all the possible outcomes, right? So that's all you need to know in probability. But very, very important is you need to know a little bit about N choose K. That is a little bit about combinations, combinatorics. Without knowing what N choose K means and does, you cannot understand these videos. So that's about the only mandatory thing, knowing about N choose K, yeah? Okay, cool. Now, let's look at what a pair could look like. So a pair could look like this. So you get 2 sevens, and then now the rest of the cards have to be different from a 7 and different from each other, right? So this is a possible pair, right? And of course, your 2 sevens don't have to appear as the first 2 cards, but you just need 2 sevens, and the other cards have to be different from a 7 and different from each other. That's all that's required for a pair. And of course, they don't have to be 2 sevens. They could be 2 fives or whatever. All right. So what is the probability of a pair? Well, it is this. Now, for each poker hand, when we calculate the probability, the denominator will be the same because the denominator will be all the possible outcomes, right? And so all the possible 5 cards that could be dealt out of 52 cards. And so 52 choose 5 here in the denominator does a great job figuring out all the possible combinations of 5 cards you could be dealt from 52 cards. That's what 52 choose 5 means. For actually calculating it, the formula is 52 factorial divided by 5 factorial times 52 minus 5 factorial. But yeah, you need to know that, and yeah, hopefully you learned that in your pre-calculus class or sometime earlier. Okay, so we've discussed the denominator, and so let's look at the numerator. So this 13 choose 1 is like you've got ace, 2, 3, all the way to a king. That's 13 cards. And so then you need to designate out of 13, one of them to be like for your pair. So this 13 choose 1 in this case is picking 7 to be the one that forms our pair from the 13 possible cards that we could pick for our pair, right? Like it could be 2 fives, it could be 2 twos, it could be 2 sevens, and so that's what the 13 choose 1 is. And then the 4 choose 2 here is highlighted, and anything highlighted is choosing a suit. So here the 4 choose 2 is doing, well, now that we've decided we've got a 7, we've picked a 7, we need 2 suits to choose from 4 possible suits. And here we've got a diamond and a spade. And so, you know, it could have been something else, right? Some other 2 suits. And so that's what this 4 choose 2 is there for, right? And so 4 choose 2 is like 4 factorial divided by 2 factorial times 2 factorial. So what is that? 2 factorial is 2, 2 factorial is 2. So that's 6. So it's saying like there are 6 possibilities of how we can pick the suits for the 2 sevens. So that's what this 4 choose 2 is doing. And then the 12 choose 3 is, well, we can't pick a 7 anymore. So that's why it's not a 13, it's a 12. And then choose 3 because like we can have any 3 combinations of cards from the 12 numbers that we have left. So we've already taken the 7. We can't have a 7, so therefore it's a 12. And then 12 choose 3 is saying, so choose 3 out of the 12 remaining numbers. And of course, the king, queen, and jack are not numbers, but you get it. I'm referring to them as numbers. And then you get what these 4 choose 1, 4 choose 1, 4 choose 1s are. So for the 3 other cards, right, different from a 7, they have 4 possible suits, and we need to pick 1 suit out of the 4 from for each one of them. So like here, this queen could have been like a queen of hearts instead of a queen of, what is this? Clover. I call it clover. But yeah, like it could have been a queen of hearts, or it could have been a queen of diamonds. So there's like 4 choose 1, which is actually 4. 4 choose 1 is equal to 4. So it's saying like you've got 4 possible choices for this, the suit of this card, and then 4 possible choices for the suit of this card, and 4 possible choices for the suit of this other card, And so that's what the numerator looks like. And I think I've sufficiently explained it. So let me know if you have more questions. But yeah, like if you actually use the n choose k formula to calculate all of these n choose k's at the top, and then if you similarly calculate 52 choose 5, then this is what you'll come up with. The numerator, all of these guys multiply to this number 1,098,240, and the denominator, this is going to be the same denominator in each of the probabilities we calculate for all of the poker hands, right? The denominator has to be the same, as I said at the start. Now, this is a huge set of numbers, the two numbers. So let me have you get a feel for what it actually reduces to or simplifies to. So it's roughly 1 and 2.4.